Hey guys, this is a lesson for solving one variable addition equations. We're going to solve real world and mathematical problems by writing and solving equations in the form of x plus p equals q and px equals q for cases in which p and q and x are all non-negative rational numbers. This is one of my favorite things to do, guys. It's so much fun. All right, let's look at number one. It says an animal rescue group in Africa is taking care of 5 injured baby pixie frogs. They plan to release them back into the wild when they're healthy. Each pixie frog needs its own terrarium. One of the rescue volunteers checks and sees that there are only 3 terrariums. Solve the equation t plus 3 equals 5 to find out how many more terrariums t, the rescue center, needs. So we're going to do this two ways. I'm going to show you the hanger method, which is one of the coolest ways to show in a variable equation. And then I'll show you using the equation. So the first thing we're going to do is we're going to draw a hanger. Okay. So a hanger is just like that, like if it were holding something, like, you know, how you'd hang a shirt or something on there. Okay. And we are going to write the expression t, or the equation t plus 3 equals 5. So this equals sign right here is actually going to be what we think of as right here. It's kind of how it balances, right? So everything to the left of the equal sign, we're going to put on this side of the hanger, and everything to the right of the equal sign we'll put over here. Okay, so let's go back and see t. So I'm going to put a t plus 3. There's 1. Oh, you guys, let me do this first. I actually need to make this a little bit smaller. Okay, so we'll do t, 1, 2, 3. Okay, so it's t plus 3. Then on the other side, we just have 1, 2, 3, 4, 5. Sorry, my hanger is a little scary looking. Okay, so what we're going to do is we're going to balance it out. So we need t to be by itself or have the same amount on either side of the hanger. Okay, so that means I want to get t all by itself. So what I would do to balance it out is I would cut off 3 of these and cut off 3 of these. So I'm removing 3 here to get t by itself. To balance it, I'm going to do 3 over here. That leaves us with t, trying to use my thing here, t equals 2. Okay, the way we can do that using our equation, t plus 3 equals 5. So what we're going to do here is we want to isolate or get t all by itself. So the operation that's happening right next to it, we want to do the opposite of to get to the other side. So we're going to balance the equation by doing the opposite operation. So if this is a positive or an addition sign, I need to make it a subtraction sign. So I'm going to do it to both sides to make it equal. So we'll do minus 3, t now equals 2. Same deal. Okay. You can see here we're using the hanger diagram to show that. So just the same thing I did on the other side is we have t plus 3 equals 5. We're removing the 3 from both sides to make it balanced, and then we would leave off with t equals 2. Okay, or we can just subtract from both sides to balance out the equation. Okay, number 2. Teresa has some photos on her computer on Monday. On Tuesday, she downloads 24 new photos. Then she deletes 9 photos. She ends up with 33 photos. Explain how the equation p plus 24 minus 9 equals 33 represents the situation. Then solve the equation for the variable p and interpret the solution. Okay, so the first thing we need to do is explain how it represents the problem. Okay, so let's just start off here. Monday, she has some photos, right? We know she has some photos, but it doesn't tell us how much. Okay, so that's some photos. That's our variable. We're not sure how many she put. But then it says she downloads 24 new photos on the next day. So there's our plus 24. Then she deletes 9 photos, right? So we know she takes off 9 off her computer. She ends up with 33 photos. So we can see why that makes sense, why the expression makes sense. Now what we're going to do is we're going to solve for the variable p to find out how many photos she started off with to begin with, right? So we'll start by writing p plus 24 minus 9 equals 33. So the first thing we want to do here is we want to combine like terms. So p is different from 24 and 9 because it's a variable, but 24 and 9 are both coefficients, so we can go ahead and combine those. So what's 24 minus 9? It's 15, right? Okay. And then we have 33 on the other side of our equation. Okay, so now this looks a little more similar to what we were doing in the last problem where we had p plus 15 equals 33. We could do this with the hanger method, but because we have larger numbers, it would have to be a little different. I could model that for you. I'll do that. So we can do, let's do p plus 5 plus 10. We could do it that way, and then we could do 10, 10, and 10. Right? Or I can do 5 and 5 is the same as 10, right? So, and then make 3. 1, 2, 3. You guys, I'm so bad at drawing these. Whoa. Yowza. Okay, and we'll do one more here. So that's a 1 and a 1. Okay, so what we could do to balance these out is take off a 10, take off a 10, take off a 5, take off a 5, and then we would have p equals, and then what's left on the other side is 10 plus 5 is 15, 16, 17, 18. So we would get p equals 18. So let's figure out if that's the same if we're not doing the hanger method. Okay, on this one here, we're going to try and isolate the p. That means we want to get it all by itself. So I'm going to look next to it at the operation happening next to it and do its opposite. So I have a plus here. I'm going to subtract then 15 from both sides to balance out the equation. So we'll have 15 here and 15 here. And what do you know? We do get a total of 18. So she started with 18 pictures on her computer and then added and subtracted all those. But now we finally know what she started off with. Okay, number 3, what is the solution of 7 plus 5 equals 4 plus y? So this one, again, we're going to combine like terms. So this 7 and 5 on one side of the equation, those are like terms, so we can combine them. But if you look here, these are unlike terms. This one is a variable and the other one's just a number, so we can't combine those together. But we can combine 7 and 5. So 7 plus 5, I always mess up with my markers here. 7 plus 5 is 12 equals 4 plus y. Okay? So usually when we think about it, we usually look next, what's happening next to it to find out what I'm doing the opposite of. And this number right here doesn't have an operator in front of it, but we know that this, because it doesn't have a negative in front of it, we know that this 4 is a positive, and the opposite of a positive is a negative. So I'm going to go ahead and subtract 4 from both sides, and that will give me y equals 12 minus 4, which is 8. So y equals 8. Looking at our last one, it says at a local gardening store, a palm tree is 1.2 feet taller than a cactus. The palm tree is 4.9 feet tall. Use the equation 4.9 equals c plus 1.2 to find the height in feet c of the cactus. Show your work. So we'll go ahead and we will do 4.9 equals c plus 1.2. Now this is the exact same thing that we've been practicing. We would just treat it like they were whole numbers, okay? So again, find your variable. Here it is. I want to isolate it by doing the opposite of what's happening next to it. So I can see here that it's being added, something is being added onto it. So we're going to subtract it from both sides to balance out. So we'll do minus 1.2, minus 1.2. Okay, and then it becomes c equals, and we'll do our subtraction here. This is 7, bring down your decimal. C is the same as 3.7 feet. Ta-da! Super doable, lots of fun. I really enjoy doing the hanger method. It's not quite as simple with decimals, but you can do it with whole numbers. It's a lot of fun. But really, what you want to do here is find your variable. You want to get it by itself by removing whatever's being done to it. You're going to do its opposite and take it to the other side.